In the movie Speed 2, a cruise ship crashes into the dock. The heroes are thrown through the windshield when the ship collides. But in reality, should the heroes be really thrown through the windshield? To find out, let's go to the Ontario Science Centre. This exhibit shows Newton's third law of action-reaction forces. According to Newton's third law, for every action force, there is a reaction force that is equal in magnitude but opposite in direction. A collision is an interaction between two objects that have made contact with each other, in this case represented by the two cards. In the collision between the two cards, both cards experience forces that are equal in magnitude and opposite in direction. Such forces often cause one object to speed up, that is gain momentum, and the other object to slow down, that is lose momentum. The accelerations of two objects colliding are not necessarily equal in magnitude. According to Newton's second law, the acceleration of an object is dependent upon both force and mass. If the colliding objects have unequal masses, they will have unequal accelerations. The ship colliding into the dock is a scenario where this can be easily seen. If we collect the data from this stunt, a velocity time graph can be plotted. From the velocity time graph, the velocity of the heroes when they are thrown off the windshield can be obtained. From the movie, we know that the heroes are thrown off at a time of approximately 33.95 seconds. From the graph, we get a velocity of 2.511 meters per second. The slope of the line of best fit is the acceleration of the cruise ship when the collision occurs. The acceleration of the cruise ship is negative 0.0134 meters per second square. This situation can easily be understood by comparing it to a car collision. A car traveling at an acceleration of above 1 meters per second square would allow a person to be thrown through the windshield. Accelerations below 0.1 meters per second square are like a nudge from a gentle breeze. As in this case, the acceleration is 0.0134 meters per second square, which is 13.4 times 10 to the power negative 1 times less than the minimum acceleration required to allow a person to slide down the deck. As the ship moves forward, it hits the dock and slows down, or in physics term, accelerates backwards. People on the ship feel as if they are being pushed forward during the collision, since according to Newton's law of inertia, an object at rest stays at rest and an object in motion stays in motion unless acted upon by an unbalanced force. This stunt is impossible due to the almost negligible velocity and acceleration at the moment where the heroes are thrown off the windshield.